Right. Now, quadratics now is a topic in mathematics, in algebra, but it's also the name given to a particular equation, the quadratic equation. So we dealt with the linear equation, y is equal to mx plus c, but the quadratic equation, I'll give you the standard form for the quadratic. For the linear is y is equal to mx plus c, or ax plus by is equal to c, something like that. There is no exponent greater than 1 for the linear. But for the quadratic now, a is a number, x. But remember, if you can recall, all equations have variables. And in mathematics, y and x are normally the standard letters used internationally for variables. You see, so because it's a language, so you have to standardize things by convention. So if you go Timbuktu, if you go Japan, if you go America, and you go in another math class, also in another math class, probably going on somewhere, and you're talking about an equation and you want to generalize, and you want a letter for the variable, because you have what you call the variable now is actually representing what is actually happening in the real world. You know, y could be time, y could be cost, it could be, because that's what mathematics does, describe what is actually happening. So y and x now are the international symbols for the variables. Okay, now y now is always the dependent and x is the independent. Y depends on x. Y is the range is the output, the input is the domain, which is normally given the letter x. But here now, the input now, the domain, the independent variable has a little 2 on top of it on the right side, x squared. Okay, so squared now, quadratic, 2, you see, because this have its origin in the languages of European languages, quadratic 2. Okay, so there's a square on top of the x, and once you see that you are in the world of quadratics. Ax squared plus bx plus c. So that's the standard, that's the general form internationally for the notation for a quadratic equation. Okay, y is equal to ax squared plus bx plus c. A, b, and c are numbers. A is the number in front of x squared, the coefficient of x squared. B is the number in front of x, coefficient of x, and c now is the constant by itself. C is the y-intercept. The graph for a quadratic is a parabola. New tab, Google. What is the graph of a quadratic equation? So that's one of the advantages, as I keep on saying, of this right now, as we are all online, a parabola. Here it is. All right, it's a U shape. But then you have an N shape, you have the U shape, and you have the N shapes. Okay, all of it is explained in the booklet, but I'm just showing it to you. Okay, the graph of the quadratic is a U shape. It's also an N shape also. When A is negative, you'll get an N shape. When A is positive, you'll get a U shape, but it's a curve. It could be U shape or it could be N shape. Okay, its name is parabola. Look at the parabola. A parabolic curve. You have hyperbolic, and you have a lot of different parabola. Okay, so we know from straight lines, we know into curves now. Okay, and we have the quadratic curve, which is either U shape or an N shape. Okay, now this is question. This is an example like question number 5. For more readings, you can go to the booklet and you'll get some more notes. You can YouTube it, parabolas, quadratics. Okay. Here the question says, question number 5 says, the diagram, see answer sheet for question 1, choose the graph y is equal to f of x where the function f is defined by, so they give us a function and they give us the domain. You have the function and you have the domain. That is standardized. It's always good to give the domain when you give the function. From the graph, write down the values of f inverse f, f of minus 4, f of 0, and f of 12. Okay. On the sheet, answer sheet, by first drawing a suitable line, draw the graph of f inverse and write down the domain and range of the inverse. Write down the domain and the range of the inverse. And you have a graph paper. Okay. And you have to use that. You can actually draw it, and you can draw it and draw your grids, or get a graph paper, and because this, you have it printed, so you'll have to draw it on graph paper. Or if you draw it on your own paper, make sure that they are equal spacing. This is 1-to-1 Fourier, and so forth. So what I did now, I went to the booklet. A lot of information in the booklet. All right. And I got an example very similar to number 5. So here it is. If you put it and number 5 side by side, you will see they're looking very much like each other. Here it is. The diagram shows h of x is equal to 2 square root x minus 4. Look at there, 2 plus square root of x plus 4. This one x minus 2, sorry, the domain. And number 5 say, look the domain. And part I say, find f of negative 4, f of 0. Part I say, find h of 2, h of 3, h of 6. Okay. So let us start. What is missing though is the part of the graph. Okay. So we have to put the part 2. Part 2 there is supposed to be part 3 for the number 5. So we will put our part, 2. We'll call that 3, and we'll put part 2 because we have to, on graph paper, draw a suitable line, all right, to show the inverse of h. Okay, after we find h of 2, h of 3, h of 6. All right. So just like all the question in number 5 say, find f of negative 4, f of 0, f of 12. Our example say, find h of 2, h of 3, h of 6. Can somebody please tell me how we can find h of 2, h of 3, h of 6? Anybody? How to find h of 2? To find h of 2, we are going to substitute 2 into h. Very simple. I know we all know how to do that. We have done that already. How to evaluate a function. So h of 2 is equal to 2 plus the square root, open bracket. So always we see x, we have to put 2. 2 subtract 2 equal. 2 subtract 2 is 0, the square root of 0 is 0, so h of 2 is 2. So that's what you do when you reach number 5, I, and you want to find h of f of minus 4. Okay, so I repeat, if you want to find f of minus 4 when you reach number 5, we all know what to do, how to find f of minus 4. We're going to find what is h of 3 now. We have just found what is h of 2. H of 3 is a similar process all where you see x, you put 3. In our case, all where you see x, you put 3. So it's 2 plus square root of 3 minus 2. The square root of 3 minus 2 is 1. The square root of 1 is 1. 1 plus 2 is 3. And you can actually prove those answers that I'm writing there. Okay, so don't just take it for granted and copy it down. Prove it yourself. So now we have to find what is h of 6 now. So just like how we found what is h of 3, when you reach number 5, if f of 0, all you do, all where you see x, you substitute 0 in f, and you'll find what is f of 0. F of 12, all where you see x, you put 12. H of 6, h of 6, so we're on h of 6 though. So it's 2, 3, and 6. H of 6, 6 minus 2 is 4. The square root of 4 is 2. 2 plus 2 is 4. Okay, so this h of 6 is actually 4. So we have answered part I. Now it says write down the coordinates of, so here's the graph. Write down the coordinates of A, B, and C. So we have to write it in terms of points. So hence, or therefore, hence the coordinates of A, B, and C are two comma 2 exactly, 3,3 exactly, 6,4. So basically that's what you do for number 5 part I. Okay. Number 5 part 2 now says to draw a suitable line, then draw the graph of y is equal to f inverse. So we're going to leave that part still, and we're going to do what we're going to answer that question. Although our example does not have the question, we're going to answer the question. Now look at what we're going to do. Okay.